Good morning, everybody. Thank you for joining our EPA Prep Week brought to you by Johnstone Supply. So this morning, Greg Millsaps is going to be going over our Type 2 equipment, which is pretty much everything that we do in the residential HVAC and even into the commercial and industrial HVAC practices. So we're going to, some of the stuff we're going to be regrouping on because a lot of it will relate back into our core class that we did. But there will be some things that are specific to Type 2. So, Greg, thanks for presenting with us today.
Hey, I'll do my best. It's been a struggle the last few days, Clifton. I've lost all you guys too, by the way, so if you put your hand up, I won't be able to see you.
That's right, I got it.
Okay, thank you. This is Type 2, something pretty much all of us need. First, I want to say that our main goal here is that you folks pass this test. I know that when we do the class in Dayton, it's the only class I have that is tense. Everything else is real relaxed, but these people are kind of job dependent on passing these things. So we're trying to get you there. So here's some of the things we're going to go over. The different ways to determine the system charge, leak repair requirements, leak repair timeframes, the regulations, which a lot of these will be dependent on how much refrigerant they hold. And we'll discuss that here in a few minutes. So technicians maintaining, servicing, repairing, or disposing of medium, high, or very high pressure appliances, except for small appliance and MVAs, which is motor vehicles, must be certified as Type 2 or universal. And universal is what we're looking to get everybody. And just a side note, Clifton, I worked for 20 years with just Type 1 and 2 in core.
Right.
Because the company I worked for really didn't want us taking 3 because they didn't want to lose us to refrigeration.
You bet. A lot of them do not promote that.
And you know, when people come in, they're tense in my class, I go, you know what? I had been a tech for 7 years, had a 3-year-old, a 1-year-old, and a wife, and I was told I either pass or I don't have a job.
Right.
So that was pressure.
Yeah, absolutely. That's why I encourage people to get that universal as soon as you can.
Especially if you're young.
You betcha.
Okay, the way to categorize the leak amounts you're allowed are 3 different categories. We'll go through them. It's comfort cooling, commercial refrigeration, and IPR, and we'll hit each one of them. Comfort cooling is just what it says it is. It's air conditioning. So whether it's a 2-ton unit in the backyard or it's a 25-ton unit on the roof, the difference is when they hold a certain amount of refrigerant, there are documented leak requirements. And comfort cooling is always the lowest. It's 10%. We'll cover that in detail. The next requirement is commercial refrigeration, something Clifton knows a lot about. These are appliances used to preserve products. Retail food and cold storage and warehouse sectors are classified in the EPA as commercial refrigeration. They have a 20% leak allowance. And the last category is IPR, which is industrial process refrigeration. And a lot of these we have one particular that I've been out on, is in a factory where they use the refrigeration process to comfort cool and for manufacturing.
Absolutely.
It's a big lab here, and actually about 65% of it is used for manufacturing.
Yep.
What the EPA determined was if it's over 55% used for manufacturing, you can use the leak rate of IPRs, industrial process refrigeration. So that's a 30% leak rate. So it's the lowest is comfort cooling, air conditioning. It's at 10%. This is systems holding over 50 pounds of refrigerant, by the way. Commercial refrigeration is 20%. IPR is 30%. But the best place to find the type refrigerant in it and the amount of refrigerant is the equipment nameplate. And you'll need that for leak rate calculations. But remember this, back to the residential side. We have a nameplate that tells us what the factory charge is, but that's only good for 15 feet or line set. And the smallest matching evaporator, by the way, something they don't actually usually tell you. But if you had a system that had 5 pounds charge in it and a 30-foot line set, then the total charge for leak rate calculation would be 5 pounds 9 ounces. Just a quick calculation on 3 ounces per 5 feet after 15 feet.
Yep.
So if you're a tech on the job and you're trying to figure the total factory charge plus the charge added, just if you can measure the length of the line set. Actually, I had a call on that yesterday in an apartment. We said, I can't find where all the line set went. I said, don't worry about it. Set your superheat.
Yeah.
So the nameplate is the easiest place to check the type of refrigerant used in a packaged rooftop unit. In addition, the nameplate will indicate the system's total charge. So on a package unit, that is the total charge.
That's right. There's no additional line set.
Yes, that's correct. It comes with that factory charge. And a lot of times with when you go to Brian's class and working with these VRVs and stuff, we don't top a lot of charges off, especially with mini splits. If we find a leak, we recover it, we repair it, we weigh the factory charge back in via the nameplate.
That's right.
And the best way to put a charge in any system is 2 wallets in a vacuum, added as a liquid through the liquid valve. Once the threshold leak, this is the EPA's requirements for systems holding over 50 pounds. Once the threshold leak rate has been exceeded on any system using an ozone depleting refrigerant with a charge size of 50 pounds or greater, the owner must repair the appliance enough to bring the leak rate below the threshold. I've always been amazed at how they word this. It doesn't sound like they're telling you to fix a leak. They're telling you if it's a 10% leak and you get it down to 8%, you're okay.
Isn't that crazy?
That's nuts, but fix the leak down to 0%, how's that?
That's right.
And here's the actual rates for systems holding, again, over 50 pounds. That is 10%, 10% annually of the charge for comfort cooling. So if it's air conditioning, they consider it a luxury, and they give you the lowest amount of leak rate possible. 10% for comfort cooling, 20% for commercial refrigeration, 30% for industrial process refrigeration, or 30% for a system that's used for more than 55% industrial process refrigeration. Those are all things that are, go ahead.
It's very important stuff. And one thing I want to point out about that is, that was supposed to go into legislation January 1st of 2019. That did not pass completely through the Senate. So that is still up for grabs. It should be through legislation for 2020. So these are requirements that are not yet in legal form, but they will be. These are the things that the EPA is pushing. There was a lot of pushback and lobbying from the residential sector because of the amount of requirements and the amount of additional time that it was going to take for companies to document all of these leak rate and leak inspections. So it was supposed to be enacted January 1st of 2019. It did not pass, but it probably will in 2020, which is why we're presenting this and preparing for it. And that IPR is actually at 51% now. So
I'm amazed that
soon to hit 51.
I was actually talking to a guy that worked with the lobbyist. I was amazed at all the stuff that goes on in the background with this. So I think the best thing to do is just kind of stay up with it the best you can.
Yeah.
Because once you're certified, and I think you mentioned this, Clifton, your certification remains. These numbers may fluctuate in the future, or they may pass different codes and stuff like that. But the certification, you do not have to recertify. You do not have to retake the test once you pass it. So that's what's important. We'll stick with the numbers, and basically what this is for is these are the numbers they're going to see on the current test, at least for the most part. So that this PowerPoint right now is not intended to teach you heating and air. It's intended to get you through the test. So that's how we're approaching it. And he's right. They're daily lobbying these different terms.
As a company, we adopted that 30% leak rate about 5 years before I even left, knowing that that was going to be a 2020 or 2019 standard. So there's a lot of companies out there that already document to those processes just because they know that they're going to be coming.
I got a question in there from Jeff about California. California is their own country, by the way.
Yeah, that's right.
So, if an appliance with 50 or more pounds as a regulated refrigerant exceeds the threshold leak rate, the equipment owner or operator has 30 days to repair the appliance and conduct an initial verification test. If an appliance with a charge of 200 pounds or more of a regulated refrigerant, you have 10 days to do a follow-up verification on it. And again, this PowerPoint isn't just here to help you pass type 2 of the EPA exam. Not having a tech. This slide, I think, of you, Clifton.
Yeah, that's me.
HCFC rack refrigerant used in supermarket. The system fails and issue leak verification. Technician has a 30-day window. I believe, if you may, Clifton, you have to check these big racks that hold a lot of, like over 1,000 pounds every 30 days or 90 days.
Yeah, so all of the 500 pounds and more, we did annual leak rates, and then we also did quarterly and monthly leak inspections, which we'll actually talk about that as we get into some of this type 3 stuff. But it follows into these same leak inspections. So it really depends on the refrigerant that you're using, whether it is a fluorine or chlorinated refrigerant, and it will depend on the amount of refrigerant in the system.
Right. Thank you. Assuming no extensions apply, a cold storage warehouse operating an appliance charged with R22 or any other regulated substance leaking above the threshold rate can continue to operate the appliance without repair for 12 months. And this one always blows me away. I was talking to Brian about this yesterday. If a system leak rate exceeds 125% of its full charge in a calendar year, you must submit a report to the EPA. That's a lot of leaking right there, guys. So a 100-pound system leaves 125 pounds. I got to fill a report out on it. You don't want to do that, by the way.
No, I actually had one.
Did you really?
I did. So I had a rack system here in Canby, Indiana that had, it was an R22. So this was a 2-rack grocery store. So that was a 1.9, so 190,000 square foot facility. The medium temp rack on it had 11 compressors and 1,400 pounds of R22. Early in the year, it had had an evaporator coil leak and it had lost a few hundred pounds of refrigerant. That was repaired and documented. And about 9 months later, a head gasket on one of the 2D Copeland compressors blew out. It had been replaced by technician, and the bolts I don't think were completely torqued down to spec. Blew a gasket and dumped 1,400 pounds of R22 in about 10 minutes.
That's pretty scary.
1,400 pound leak rate turned into a 1,700 pound leak rate that had to get an EPA report for it. So
that's amazing.
Yeah.
Plus expensive.
A big cloud over that building.
Yeah. Can you imagine what those two fans are? 32-inch diameter exhaust fans. Can you imagine what they look like coming out of the top of there when that leak sensor went off and it went? Yeah.
I can note one thing too. That's a cumulative leak rate. So
over a year.
Over a year. So if you lose 100 pounds in the first week, and then 100 pounds next week, that adds up to that 125%.
You betcha.
Right. So all these things are considered as an annual leak rate for systems over 50 pounds. And that's why I picked on Clifton a little bit here, because that's the world he came from, not the world I ever lived in. So this slide is also about that. It's if you have an appliance using an ozone depleting refrigerant, it does not need to be removed or mothballed by storing in a warehouse. So you don't have to take it and remove it. And the one below it, there's system racks that I seen in a commercial building one time that they were able to isolate the leaking component in there.
You betcha.
By shutoff valves and to recover that particular section without having to shut down the entire system.
Right. So that is our mothballing.
That is mothballing it for until you can make the repairs, I'm assuming.
Yes.
The owner operator has 18 months to retrofit a retired leaking appliance if the replacement appliance will use refrigerant exempt from the venting prohibition. So they give you an extra 6 months if you're going to go to a non-ozone depleting refrigerant.
Correct.
This eye chart, a lot of people lose their minds on because they're trying to memorize everything on here. And I try to say, keep it simple. Comfort cooling, 50 pounds or more, 10% leak rate. Commercial refrigeration, 50 to 50, 500 pounds, excuse me, it's 20 or 30%, depending on whether it's considered industrial process or commercial refrigeration. More than 500 pounds is 30% or 20%, considering what category it falls into. So don't overthink it. The ones Clifton was just talking about, with 500 pounds or more of ozone depleting substance or substitute refrigerant, require a leak inspection to be conducted every 3 months. So basically, I guess you're going in and calculating the leak rate every 3 months.
And doing an entire leak inspection. And remember, that's a leak inspection.
That's a lot of work.
So every grocery store in the United States that has 500 pounds or more of refrigerant in it is required for that entire store to have a leak inspection every quarter. So every quarter I went to every one of my stores and I did an entire store leak inspection. Usually it took a day, sometimes 2.
Wow.
Yeah.
Based on the section 608, here's the big stuff. Leak repair regulations chart: an industrial process refrigeration system containing 1,000 pounds of R22 that has exceeded the applicable leak threshold must be inspected every 3 months until verification that the leak has not been exceeded for 1 year after repair. Kind of system you were just talking about, Clifton. This is good for all techs to know, whether they're residential or commercial, to keep records, initial leak verification, follow-up verification tests on file for 3 years. We did it even in residential. We put the amount, the type, and the address of every time we added refrigerant or removed refrigerant.
You bet.
And the best way to check for a leak is still nitrogen, in my opinion. It's an inert gas. It doesn't hurt anything. You can pressurize it. We'll get to that with a trace amount of refrigerant, and that's this slide here. A lot of guys tried to get away with some stuff by putting refrigerant or putting nitrogen in systems that were almost fully charged in order to vent them. That is against the law. So you can just put a trace in there, and the only reason they let you do that is because the leak detector might be looking for the refrigerant itself.
Right.
So I like this right here personally. I find 90% of my leaks by finding the traces of oil. It used to be a little more prevalent with mineral oil. It seems like it just easily showed up.
Mm-hmm.
But you can still find traces of oil. And then I go to the soap bubbles. In this particular case, a little more difficult in the inner workings of a condenser. But I've seen this on more tests than I can count. The traces of oil. Rotating shaft seal is where they tend to leak on a belt drive compressor, especially one that hasn't been operating for a while. So the shaft seal will be the most primary place for the leak. And it's probably actually true. And we also pinpoint leak with soap bubbles. It's kind of redundant, but this is the way I've always found leaks, by the way. Interesting slide here. It tells you if you have high superheat on a cap tube or a piston, you might have a leak. It's probably low on charge with high superheat, considering all the other factors are good, like airflows and such as this. We use subcooling on a thermal expansion valve and electronic expansion valve to determine if the amount of refrigerant is adequate. So just a couple ways to determine if indeed it was ever correct to begin with. High superheat or low subcooling might be an indication that you've lost some of the initial charge. This is kind of interesting. A lot of guys don't know this. Those service type 2 stationary refrigerant appliance must own active recycling and recovery equipment. And I tell every heating and air company, every maintenance department that does HVAC, you have to have a recovery machine on site that will stand alone and remove the refrigerant from the unit with nothing operating on the unit. So you could take all the electrical controls out of it. This machine can take the refrigerant out of it. But once you purchase one, you do not have to report it to the EPA. They expect you to have it, but you don't have to send them a letter telling them you bought one. Before you recover refrigerant, determine the maximum amount of refrigerant that's contained in the system. This is probably going to be on the nameplate. So if the nameplate reads more than 15 pounds, it cannot be a system-dependent recovery process. You can't use the compressor in a system to recover it without a recovery machine if it's over 15 pounds. This particular one's 13.94, so you could use it. I think we covered that in the early, probably in the core somewhere.
Yeah, and a little bit in type 1, yeah.
Yeah,
a little bit type 1, yeah.
I know Brian covered it yesterday on passive and recovery and system-dependent recovery, so I'm not going to go into service valves. We covered this yesterday too, the burnout. They want you to be careful when you're recovering something that it's not contaminated, which is going to contaminate your whole recovery cylinder. So it can cause you some problems expense-wise down the road. Self-sealing connectors or hand valves. A lot of guys like these ball valves. I'm with Brian. I like the quick release valve. Really don't use any refrigerant. And we also taught our guys in the field a practice of taking the high side off while it was running with those particular fittings in there, and then throttling your gauges to push that liquid back into the system, especially in a critically charged application, so that you're not removing 3 to 4 ounces every time you take your gauges off.
Right.
So it's kind of a technique we taught to, especially when we started going to microchannel, critical charge heat pumps and stuff like that. So if you're servicing it twice a year, you could be removing 1/3 of a pound every year out of there. And then in a couple years, you're looking for a leak that doesn't exist. So
exactly.
Yeah, try to use some good practices when it comes to removing your gauges. We did this as well, and I think Brian mentioned this yesterday. I know Clifton did in the core. His cylinders should be evacuated. All the cylinders we have at our shop that we sell are in a vacuum. But the techs, when we had techs in the field, we would bring them in and recover them into a large cylinder. I think it's 500 pound or 1,000 pound cylinder. And then we'd put a vacuum pump on our recovery tank, and we'd actually pull a vacuum on them.
Yep.
This is like a rack system I was talking about earlier, Clifton's specialty, where you might be able to isolate a certain rack or section to recover it, to keep the rest of the refrigeration process going, because it could be very expensive in the world he used to live in to have these things down. This is
It's a
I
water
love this
cooled.
slide, Clifton.
Mm-hmm.
Recovery machines that utilize a water-cooled condenser must be hooked up to water.
Yeah.
You got to have a water source for them.
Gotta have
like,
water for
I'm
water
always
cooled.
like, really?
Yeah.
So, but this is probably for very large recovery systems. Like Clifton's talking about recovering 1,200, 1,400 pounds. I mean, we know how difficult it is as service techs just to recover 8 pounds sometimes from a system.
Yep.
To reduce recovery time, connect one of the service hoses to the liquid line and recover in the liquid phase. This is a practice we almost always did on the residential side. We would pull liquid first or initially to speed the process up, and then we would pull vapor. So we'd actually get it all out of there, or at least down as far as we could. So, but vapor takes a lot longer, but you're not going to pull as much oil out. There's one of the dangers when you pull liquid is that you're going to reduce the amount of oil inside the system and also push it through your recovery tank. So, refrigerant had been recovered from an air conditioning system and held in a refillable cylinder may be charged back into the system after the repair. Another practice we did, and not to just drag on about this, but all our techs carried a clean 10-pound cylinder in their truck. We had a 50-pound R22 and a 50-pound 410 in the service vans, but we also had a 10-pound that they basically offloaded and then pulled a vacuum on, so that they were working on a system they were going to put the refrigerant charge back into. They put it in this 10-pounder, which held almost all residential back then. And then they could do the repair, evacuate, and put the refrigerant in the homeowners already paid for when they bought the system.
You betcha.
So, especially as refrigerant got more expensive.
It basically just becomes a liquid line receiver.
It does. You're just kind of pushing it in. That's exactly right. And you know, again, we're trying to be fair to the homeowner. As R22 especially got so expensive, we were just trying to, well, we'll just recover it in this and not into the 50-pounder, which means we could be exposing them to somebody else's refrigerant, which is actually breaking the EPA regulations. So again, keep your records for 3 years. We kept them by address, amount and type refrigerant we used. And it didn't matter if it was 6 ounces or 6 pounds.
That's right. So, I mean, this is all residential companies.
Yes, and they really need to be
50 pounds.
Due diligent on this, because you never know when somebody knocks at the door. And basically they can recover how many barrels or drums you bought over the year, and you have to account for where that went. So, and just be careful. It's not that hard to do. We didn't like it at first, you know, not in the 90s, but it just became a part of everyday life. So let me back up here. We do this all the time in the field. Cooling the recovery cylinder. Not many people have a block of ice to stick it in. But if you've ever out there in the system and you're recovering, especially if there's quite a bit of refrigerant or non-condensables in it, it's a nightmare. And that tank gets very hot. And as this tank heats up, the pressure rises. And just common basic science here, if the pressure rises, it's harder to put more pressure in it. So basically, we usually just took a hose and cooled them down. And the other side of that is you can warm the system up. I think Brian mentioned yesterday turning on crankcase heaters or defrost controls. Yeah, you warm the refrigerant up and it increases the pressure and it's ready to leave. Decrease the pressure of the recovery cylinder and it's ready to accept. So it's kind of just simple science. Temperature recovery units compressor, they do use the flow of refrigerant to keep them cool, just like our air conditioners do. Almost all residential air conditioners use the refrigerant to keep the compressor cool. So had this happen actually last year, I think, Clifton, you'll remember, a guy made a repair on a service valve, pulled what he told me was a 300-inch vacuum or micron vacuum, and he turned his system on in a vacuum. So he said it had to be running to weigh the refrigerant back in. I'm like, no, it didn't.
You're already in vacuum.
Should have weighed it in through the liquid line as it was in a vacuum. So he actually tore his compressor up. I mean, trashed it.
Yep.
He put 240 volts to under a 300 micron vacuum, and I seen what it did to it.
Well, it's like when we talk about, you know, older televisions and amplifiers, you know, we ran that power. We increased our power by running it through a vacuum tube.
Wow. This is another one of those charts where I tell people they're always going, hold on, I got to write all this stuff down. No, you don't have to write all this stuff down. Very high pressure and high pressure appliance for less than 200 pounds, 0 inches mercury evacuation. High pressure appliance over 200 pounds, 10-inch, medium pressure, less than 200 pounds, 10-inch, and medium to high appliance over 200 pounds is 15. And this is basically example when more than 200 pounds, 410, must evacuate to a level of 10 inches mercury. Always remember this, no matter if you're doing a residential or commercial, after you reach a required vacuum level, shut it off and wait for a few minutes to see if system pressure rises. So you're looking for if there's still non-condensables in there or if it actually has a leak. If it has a leak, it'll go back up to atmospheric pressure because this is what this says, which is 14.68 psi per square inch, I think. So you will eventually work your way out of a vacuum completely if there is a leak.
Mm-hmm.
Don't use your suction gauge to tell you if it's a deep enough vacuum or if it's got a leak, by the way. The refrigerant receiver, something is typically found in the liquid line at the outlet of the condenser. It's a high pressure liquid on the receiver. It should be pumped down and isolated in the receiver. A lot of times when we pump a system down, we create the condenser to be the receiver, and it accepts all the refrigerant as it came from the factory in the first place. So everything, not all equipment has these receivers, by the way. We used to have a lot of sight glasses in systems. I don't know if they're as prevalent anymore. They used to be used as, not as much?
Not as much.
No, they used to be used a lot with thermal expansion valves as a way to hayseed check the charge on it, kind of clear the sight glass. We used to, in the old days, you'd block the coil off to 280 pounds and clear the sight glass. Believe it or not, that was a kind of a way we used to charge systems back in the day. We still did that with our.
They can't do that anymore.
No, we used to do that with car air conditioners. Like, your buddy pulls a car in the driveway and hands you a 6-pack, and you'd grab your R12 drum and clear the sight glass for him. But those are real old days there.
Yeah, I mean, with the new refrigerants, the blends, you can still get bubbles in them.
Right.
Yeah, that's right. So it's not an indicator that it's actually accurately charged. We use different methods, whether it's subcooling, superheat, a combination of the two, which I always use. Or the best way to charge a system is to weigh it in an initial after measuring the line set. But as Brian always says, always confirm with subcooling and superheat. Anytime a system is open for service, the liquid line filter dryer should be replaced. This should be just something you do as a habit prior to pulling a vacuum, but it is there to help remove moisture and sometimes other things, acidity from the refrigerant. I can't tell you how many times I've seen this on the test. It's okay to use an alcohol wipe or alcohol spray to remove ice from a sight glass. So that's acceptable. Something I want to cover here real quick, because I had guys ask me, the liquid line is where the receiver is. So the receiver is usually in the high side and the accumulator is in the low side. And it's usually prior to the compressor. So both are used for storing liquid refrigerant. So we usually see these accumulators and heat pumps because the conditions change when it's running. It's not using or utilizing the entire refrigerant charge. So we have to have a place to put that charge to not get it into our compressor. This is an accumulator on the side of this rotary compressor over here. So, and this is basically what techs are used to seeing in their heat pumps. And they will cover, might need you hear Brian, about 70% of the full charge you can usually get in the accumulator.
Yeah.
Yeah, so they actually hold quite a bit of refrigerant because they know that thing may be running down to 0 or lower temperature. So I'm not gonna spend time on the valves. Never run I know the semi-hermetic compressors, they never want you to start them with the discharge service valve closed. You can damage the compressor. You can actually cause personal injury too. To help prevent compressor damage, refrigerant systems must be protected by a high pressure relief device, maybe the compressor external relief valve. Some of these are, like in residential units, they're usually like an internal valve, like a check valve or something like that. It keeps them from overpressurizing. Crankcase heaters, we talked about this earlier, reduce the amount of refrigerant in the oil and to reduce oil foaming. Almost all heat pumps will have some kind of crankcase heater, either a wrap around on the right or a submersible in a well on the left. And if you have one that's wrapped around or submersible and goes bad, you can replace it with a wraparound. Anything to keep the oil warm enough to keep the refrigerant from migrating to it. Again, check for burnouts. You want to check the condition. We used to carry a little kit, burnout kit, sampling kit for the residential ones. It was kind of a quick check to see if we had any burnout. Very important here. The 4 components that the EPA defines as a major repair are compressor replacement, evaporator coil, condenser coil, or auxiliary heat exchanger. That's how it's worded: compressor, evaporator coil, condenser coil, or auxiliary heat exchanger. Those are major repairs. They consider if you have to remove, replace one of those things, or even repair them, it's considered a major repair. Microns is how we check to see if we get the proper vacuum. We've covered this before, but usually 500 microns is acceptable. We would like to get lower than that. You can't over evacuate it, but depending on if you have clean oil and what the length of your line set and a lot of other things, you should be able to get them down to 500 microns. We like to triple evacuate. Brian does this in his class, and I know Clifton does as well, is to evacuate it to 4,000 microns, I think, break it with nitrogen down to 1,500, break it with nitrogen, and then down to your 500 or lower microns. Get triple evacuation. If non-condensables such as air or dry nitrogen remain in the refrigerant system, discharge pressure of the system will be high. Believe it or not, any non-condensable will cause your head pressure to be high. In fact, I actually had a situation where we at least determined there was, what is they use to leak check in the factory? Helium? I forget what it was, but there was actually a dirty air inside the system and the head pressure was going crazy. So we actually had to remove the refrigerant, evacuate it, put virgin refrigerant back in it, which was the only way we got the head pressure down. So we determined that there was some non-condensable inside of it.
Right.
And I believe in working with a man on that one, that they think it just got left. I think it was helium they used in the factory to check for leaks. Nitrogen tanks are under high pressure, require a pressure regulator. Brian touched on this yesterday, but we can't touch on it enough because I still have techs around here that want to take that 2,000 or 2,500 pounds and think they can throttle it through their gauges.
Right.
It's a very dangerous thing to do, guys. So basically, a good regulator is going to give you the tank pressure and allow you to adjust the outlet pressure before you send it downward into your system. So, because it can snap the low pressure gauge in a heartbeat. Never install pressure valves in series, only in parallel. I don't work on a lot of chilled water systems, but they want to keep it 410 at a PSI of 110 to keep the temperature at least at 36 degrees to keep the water tubes from freezing. So there's a little flinch room there, but these pressure temperature chart relationships have been throughout this entire presentation, and these are important. As techs, we know that R22 say is 57 PSI, I think, to stay above freezing, and R410 is right at 99 or 100, I think, to stay above freezing. So we always correspond the pressure to temperature, and pressure temperature charts are a good thing to be able to read, and I think we should be able to read them by now because we went through them several times. Another example on the bottom here is knowing the relevance of the refrigerant you're working on to the temperature it's in. Once it's in a stable condition and there's any liquid at all, the pressure should match the temperature surrounding it, or the ambient temperature. And it's a good thing to know because we've had a couple incidences here where the technician thought that another company put the wrong refrigerant in the system.
Right.
By the color of the drum the homeowner described, by the way. So I said, has it been off for a while? And he goes, yeah. And I said, take an accurate temperature, put your gauge on it, and see what the heck it reads. You know, if it's 410, it's 80 degrees, it's going to be 238 or right around there. If it's 22, it's going to be around 144, by the way. There's almost 100 pounds difference. If it's 170, you probably got an issue.
That's right.
So just a good way to use a pressure temperature chart to get you out of some trouble. And then I'm not going to spend a lot of time on that. ASHRAE standard 15 requires the use of sensors to detect the presence of refrigerant, with a few exceptions. Some of commercial buildings and big maintenance rooms have some of these sensors in there that will actually bring on an evacuation system or a mechanical ventilation system. In some rooms with 717, which is that ammonia?
Yeah.
Okay, our 717 is ammonia. Some of these are always ventilated. So you have to be careful. I actually had a friend that had some problems because they were doing some brazing in a mechanical room. The levels of phosgene were so low, because if anybody's ever inhaled phosgene, you don't stay there long. But they were so low that it caused him some health issues later because he stayed in the room and it wasn't ventilated. So Well,
Yeah.
I didn't think I'd get through that quick, Clifton.
How about that? See?
Yeah, I'm going to try and see if I can pull you guys up in case anybody has any questions.
Yeah, absolutely. You know, and one of the things you want to go back to too, Greg, is if you can pull it up. If not, we can just talk about it. Understanding what those leak rates are. So when we're talking about type 2, we're talking primarily comfort cooling. So a comfort cooling system can be an air conditioning or heat pump system in a residential that has just a few pounds of refrigerant. It could be a 20 or 30 or 40 or 60 ton packaged air conditioner, or it could be that 250 ton chiller that is sitting outside or in a mechanical room that is providing refrigerant for a whole bunch of different indoor heads. It could be a VRV system that has a single condensing unit and has multiple indoor units. And so depending on how much refrigerant is in that system and what your application is going to dictate what that leak rate is. So if we're just talking about comfort cooling, if it is for air conditioning, it has a 10% leak rate. So if it's a system that has 10 pounds in it, if it's leaked 1 pound, we now have to go find that leak and we have to document it. If it is a system that is used for commercial refrigeration, so say it's being used for running coolers and it's running freezers, we know that that's not really an air conditioning system, but it is now going to be a refrigeration system that is in our field. As we progress into these type 2 and type 3, we're just following this lineage and we're getting set up for that next level. So if you're working in an air conditioning environment, you could have refrigeration systems in that same building, right? So what they're saying is if you encounter a refrigeration system, you are allowed to have a 20% leak rate on it. So if it was a 10-pound system, if it leaked 2 pounds of refrigerant, we are required to go find that leak. It's not just that we can go to the home or go to the business owner and go, hey, you've got a leak. I'm going to add 2 pounds of refrigerant. Now you're going to be required by law that if it has leaked those 2 pounds on that refrigeration system, you as a technician are required to at least fix that leak or inform that owner that they have met a federal regulation on their leak rate and they are required to have this repaired. It has to be documented. It's all about keeping these, and this is all of our exempt refrigerant or non-exempt refrigerants. So anything that has, the fluorine and chlorine, our HFCs, our HCFCs, CFCs if you happen to run into them. So if it has a fluorinated or chlorinated refrigerant, we're just now saying, hey, you can't just let these things leak anymore. If it's an industrial system, it's used for industrial manufacturing and processing. If it's a 100-pound system and it leaks 30 pounds within a year, they are now required to fix that, and you are required to inform them of that leak. That's what this 10, 20, and 30 is pertaining to. So, in the days of old, if a system had a leak on it, it wasn't required by law to fix that leak. It now is going to be required by law to be fixed or to actually be condemned. And we'll talk about that a little bit more as we get into our type 3 requirements.
I think I'd like to piggyback on that because I know that that's also the importance of keeping accurate records.
Yeah.
We probably, as a rule, as a service company, didn't do leak repairs if we went out and put a pound or less in a unit and it was the first time we'd ever been on that unit because we don't know what the past was on it. But by keeping accurate records, we could establish the leak rate size even before the government determined we had to fix them because we were trying to figure out. And a lot of times what will happen is if you charge a residential air conditioner in the spring and it runs all summer, but the next spring it's quite low, a lot of times it leaks at the evaporator because that's a coil that's been heated over the winter and expanded the refrigerant and it leaked at a faster rate. So you just try to determine through the leak rate where the possible leak would be because a lot of guys have a lot of trouble finding leaks. I didn't seem to have that much trouble, and I didn't use electronic. I was never any good with them. But by establishing good, clear records and by using proper practices, like I said, of removing the refrigerant and putting it back into the liquid line before you leave the job. So we actually had a system where you gauges going on and off were vital. We put them on when the system was not running because we didn't want to dry start one in case there wasn't anything in it. Then we took them off in the proper sequence. With it running, high side came off with a low loss fitting. We throttled the gauges and circulated the liquid back in, and we took the low side off while it was running because it is under lower pressure.
Right.
And then we had our gauges off with almost nominal loss of refrigerant, and also kind of a safety factor for the tech. But as I stated earlier, we don't want to remove 6-9 ounces a year from this machine and then start looking for a leak. I think there's a question up there, Clifton. I can never see it.
Yeah, there's a couple questions, and they are very good questions. So one of the questions was, if a leak cannot be found, can you add stop leak to that system and be sufficient as a repair? And it is no. So the answer is, if it has a leak, a known leak, it has to be found. By law, it has to be found. So it can turn into a very lengthy process, especially if we get into larger, pieces of equipment and larger structures with lots of line sets. It then turns into a bigger job that has to be taken care of. And another question that was brought up was, as a business owner, do they need to keep a separate log, or will a CRM system work? So that is actually one of the reasons that you're starting to see new technology coming into equipment that will actually record. So like if you talk about some of the new refrigerant scales and refrigerant recovery equipment, they are actually Bluetooth connecting with your mobile devices like Service Titan and Measure Quick and some of these other electronic medias, so that can all be digitally stored. Johnstone has actually been working with CPS to implement a refrigerant scale that will automatically record your refrigerant charges off from your scales into your service documentation for you. So you have an electronic file of that. So it can be done either way. It can be done by the service contractor, but inevitably it is the responsibility of that building owner. So as a technician and as a business, a contractor, we need to provide this information to the home, or to the homeowner, or to the property owner, because
Agreed.
a lot of the times those property owners are not going to be 100% thorough on what the information that they're giving. If you have a large system, say we've got a large air conditioning system. So say we're using a chiller system for a hotel that has, it's a 250-pound system that is operating, a variety of indoor air conditioning products, and it's hit that 10% leak rate. That business could potentially be notorious for putting in refrigerant year after year after year after year instead of repairing the leak when it was supposed to. And that's
Right.
what these new regulations have come into play for. They're saying you cannot do that anymore. We are going to stop these bleeding pieces of equipment that are in our industry. And here's how we're going to do it. We're going to put federal regulations on it that says if someone finds that leak, which would be us as technicians, that piece of equipment is required to be repaired. If that business owner refuses to repair that, EPA will now be able to come in and go, hey, you had 12 months to repair this. You did not. I'm walking over here right now and I'm red tagging the electrical for this system. And this system now cannot be repaired. We'll talk about that a little bit more tomorrow on Type 3. So federal regulations actually can now condemn a piece of equipment and require it to be removed, not even repaired. It has to be removed from operation if that business owner refuses to repair it. So it's really about covering ourselves more than anything, because that business owner could say, no one ever told me. And you've got a sticker on that piece of equipment that says Beck Mechanical and has a phone number, and that EPA, which by the way, EPA is looking to add a significant amount of investigators to the program. That EPA
That's
inspector,
what I was wondering about.
if there's
ever going to be any enforcement.
It's on it now. So that EPA inspector calls Beck Mechanical and go, hey, I'm down here at Joe's Bar and Grill, and this piece of equipment has had significant leaks to it, and the business owner is saying they were never informed. And you go, here's my documentation. So Yes, it is absolutely significant, because if it is not properly documented, that comes back to a knowing release of refrigerant, which means your EPA license can be revoked.
That's correct.
So be
I think
very
it's
diligent.
cover yourself, cover your company, and cover the person you're working for.
You
I mean,
betcha.
just make sure you keep accurate records.
Yes. It's
So,
what it
and it's
really
going to be
comes
more
down to.
prevalent in the future.
Yeah. So anything, especially HCFC type refrigerants, if it's an R22 system, keep very, very good documentation on any leaks on that system, because it is becoming a much higher priority than it was in the past. Remember, when we were just talking about this in core, things are changing, and they're
Yeah.
changing quickly, and we just want to keep you informed of what those changes will be. So a lot of good stuff, Greg. Thank you.
Good questions. Yeah. I mean,
Anybody
it's
else have?
interesting where we're going. And I think that I know Clifton is like me, that we just want people to be successful when they take this test. We want you to be part of the HVAC fraternity, because we're definitely needing people. Everything we do starts with safety, though. And I know Clifton covered it, maybe even Brian, on some of the refrigerants coming out that are flammable. So, you know, we had this charge years ago when we went from 22 to 410 with the pressure differences. So there was a safety factor there. But, you know, when I took the first EPA test, as these things have migrated or changed, I'd never heard of 410 in 1994 when I took this test.
Right.
So things are going to continue to change. We're just doing our best to stay on top of it, keep you informed, and keep you safe. So
That's exactly right. Any other questions out there? Brian, Paul, anything you'd like to add?
I want to say one. I would like to mention one thing that you brought up. That scale, that thing, if you haven't used it, is pretty awesome.
Yes, it is.
I've done some. I did some testing with it, and I think you did too.
Yes.
It takes, like, so you can use the GPS. It uses the GPS location off of your phone to tag the weight from the refrigerant. So when you set your tank on there, zero everything, once you start pulling refrigerant out of it, it immediately tags it to the GPS location where you're at.
wow.
That takes
Yeah.
all the reporting side of it. That, I mean,
You don't
takes
have
care
to
of all
do
that.
any. No manual documentation.
No, you
It's
don't do
done
any.
for you. So that comes back into that question
Yeah.
about, will CRMs be sufficient? You betcha. That's why they're going to be more prevalent. You know, there's so many aspects of that that can be handy. You know, what if you were that supervisor that just had a rack that lost 1,400 pounds of R22? Wouldn't it be nice to know exactly how much 22 was in every facility that you have and every service fan that you have? Because it's tracking every tank. It's registering every tank and how much refrigerant is in each tank. So yeah, lots of cool changes.
That's crazy.
Industry. All right, well, I think we'll wrap it up for the day, everyone. Thank you for joining us, and I will see you tomorrow as we dive into Type 3, and then we'll do some review. Everybody have a good day.
Have a good day, everybody.
All right, see ya.